pleasure, friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class, that is of course being important one. So in terms of physics, we have to deal many of the topics related to it. We had done your unit 1, which is your physical world. Unit 2 is your units and measurement. Unit 3 is your motion in a straight line. And now we continue with motion, unit 4, which is your motion in a plane. So that what we'll have to discuss here. This is your class 30th. We had done your 29 classes in this, what we had done here, whatever the units I told you. And this is your class for class 11th NCRT. Now we talk about for the detail. We had done acceleration related to velocity in the 2 dimensions, and which many more questions related to it. Now today we'll start discussing about the projectile motion, which is of course the important one. So yes, we go for it. In terms of projectile motion here, so as an application of the ideas that is being, first we go for projectile motion. In terms of projectile motion as an application of the idea that is developed in the previous section, we considered the motion of a projectile, and an object that is in flight after being thrown or projected in is called a projectile. So that such thrown that is your such a projectile might be a football, a cricket ball, or a baseball, or any other object, and the motion of the projectile motion be thought of a result of two separate simultaneous occurring components of motion, where one component is along with the horizontal direction without any acceleration, and the other along with the vertical direction with constant acceleration due to the force of gravity. It is also it was Galileo who first stated that the independency of a horizontal and the vertical component of the projectile motion is in dialogue on the Great World System, which is in 1632. For that, here it was discussions that we shall be assuming for the air resistance that has been negligible effect on the motion of the projectile. We suppose that the projectile of launched with that is with velocity v naught, and that makes an angle of theta naught with x-axis, and after the object that has been the projectile projected by the acceleration acting on it in that due to the gravity which is directed vertically downward. So for that, first we'll go for the projectile motion here, the definition of projectile motion. So an object that is in flight after being thrown or projected is called a projectile. So for the same here, and as I told you, directed to vertically downward, which is a equals to minus 9g, or ax equals to 0, ag equals to minus 9 minus g. Or the components of initial velocity of v naught, so v ax equals to v naught cos theta and VAY equals to V naught sine theta. Yeah. On the same way, if we take the initial position, that to be the origin of the reference frame, we have x naught equals to 0 and y naught equals to 0. And if then that is become x equals to VAX t equals to V naught cos theta 0 t, and y equals to V naught sine theta 0 t minus half gt square. The components of the velocity at a time t that can be obtained: Vx equals to Vax V naught cos theta 0 and Vy equals to V naught sine theta 0 equals to gt. And for that we have a graph here as well, so we draw the graph as well. This is x, this is for y. Here v sine theta 0 from 0 is cos theta 0 so V naught making an angle theta down, but it is a equals to minus j cap. Okay, this is a motion of an object projected with velocity v naught at an angle theta naught here. On the same way, when this for that gives the x and the y coordinate of the position of projectile at a time t in terms of the two parameters, the initial speed v naught and the projection angle theta naught. You have to notice that that the choice of mutually perpendicular x and y direction for the analysis of the projectile motion that have resulted in a simplification, and one of the component of velocity, that is your x component, remains constant throughout the motion, and only the y component that changes like an object in a free fall in vertical direction. This is shows graphically at a few instances, and you have to note that at a point of maximum height v y equals to 0, and therefore y equals to, so that is your g equals to here q, then inverse v by vx equals to 0. Now we discuss about the equation of path of a projectile. So we go for it. Equation of path of a projectile. So in the same way we discuss that. What is the shape of the path followed by a projectile? And this can be either seen by eliminating the time between the expression for x and y as to be given here, and that is being obtained. So for that we have to go for it, and let's find out. For the same, where we're gonna obtain it, and that has been as follows. So y tan theta naught x minus minus g 2 v naught cos theta naught x square. So now since g theta naught and v naught are constant, is the form y equals to ax plus bx square, and in which a and b are the constants. So this is the equations of parabola, that is the path of a projectile is a parabola, and that detail about of parabola you have discussed in the mathematics if you are from that background, and if you're not, you can just tell me in the comment section. I will be surely help you out. So for the graph of projectile, we having x-axis 0, this is y-axis. This is v naught. From here it is v naught y j cap, here v naught x I cap, and from here it is okay. So here it will be making, so just for x-axis along with the x-axis and the y-axis it will made, and then it will be having maximum height as well. So we go for it. So it will be it will be along with this is your v y j cap, v naught x I cap, this is v. Then we have your theta equals to 0, vy equals to 0, v equals to v naught x I cap. Here this is v naught x I cap, vy j cap, this is v. Another is this is that what I had drawn here. It is your it is in revert. This is theta equals to minus theta naught. This is your v, and this is vy j cap equals to minus v naught y I cap j cap. The path of a projectile is a parabola, that is being has we are dealing here, so which is being left out, and this is all our will be range. So this graph is all about, this is the maximum height, okay, and so this is the graph is related to the path of a projectile is parabola. Okay, now on the same way we discuss about it, we'll discuss the another topic, which is the time of maximum height, and we go for it. Time of maximum height. In terms of time of maximum height, where how much time does the projectile take to reach the maximum height, let this time be denoted by Tm, where since at the point y equals to 0, and we have from this equation, which is your vy equals to v naught sine theta naught minus g Tm equals to 0, where Tm equals to v naught sine theta naught by g. So the total time Tf total time TF during which the projectile in flight that can be that can be obtained to the putting y equals to 0 in, and that is your TF equals to 2 v naught sine theta naught by g. So TF is known as the time of flight of projectile. We noted that here, and in the same way TF equals to 2 and Tm, which is expected because of the symmetry of the parabolic path. Now we discuss the maximum height of projectile. So we go for it. Maximum height of a projectile. So on the way, the maximum height of projectile, that is HM, that reached by the projectile, that can be calculated by substituting T equals to Tm. So for that, I equals to HM V naught sine theta naught V naught sine theta naught by G minus G by 2 V naught sine theta naught by G का square. So for that, further it will be, or we can say that HM equals to V naught sine theta naught square upon 2G. Now we go further, we'll discuss about it. That is the horizontal range of a projectile, and that we have as follows. So for the same, it will be your horizontal range of projectile we discussed. So horizontal range of projectile here, the horizontal distance that is traveled by the projectile from its initial position x equals to y equals to 0 to the position where it passes to y equals to 0 during its fall, that is called the horizontal range. And r, which is the distance traveled during the time of flight, dj. Therefore the range of r is being as follows, and that is your r equals to v naught cos theta naught df equals to v naught cos theta naught 2 v naught sin theta naught by g, or r equals to v naught square sin 2 theta naught by g. So equation that shows for a given projectile projections velocity v naught, and r is the maximum when a 2 theta naught is maximum, and that is theta naught equals to 45, and the maximum horizontal range is therefore will be rm equals to v naught square by g that we have. So for the same, it will be we go for the same, and we'll go to discuss about the numerical here, which is also been the important one. The numerical we have is to Gallium. In this book, two new sciences stated that for elevation which exceeds or falls short of 45 degree by equal amount, that the ranges are equal, prove the statement. So let's prove that statement as well. So here we go. Question is, Galileo in this book, two new sciences stated that for elevation which exceeds or fall short of 45 degree by equal amounts, the range are equal. Prove that statement. For projectile launched with velocity of v naught at an angle of theta naught, so the range will be r equals to v naught square sine 2 theta naught upon g, where now for angle 45 degree plus alpha and 45 degree minus alpha, so 90 degree plus 2a and 90 degree minus 2a respectively, that the values of sine 90 plus 2 alpha and 90 minus 2 sine 90 minus 2 alpha, that the same equals to that of the cos 2 alpha. Therefore the ranges are equivalent to the elevations which exceeds fall short for 45 degree by an equal amount of alpha. Now here we're gonna discuss about the another question that is of course being important one, and that we have as follows. So we go for another question that we deal with it, which is the question is a hiker stands on the edges of the cliff for 90 meter and above the ground and throws a stone horizontal with an initial speed of 15 meter second inverse. Neglecting their air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. That you have to answer it out here. So let's go for the same. So here we go. The question is, a hiker stands on the edge of a cliff for 90 meter above the ground and throws a stone horizontally with an initial speed of 15 meters second inverse. Neglecting air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. You have to take g equals to 9.8 meters second inverse. Now for the same we go for it. We choose the origin of the x and y axis at an edges of the cliff and t equals to 0 second at an instant that the sense is thrown. Choose the positive direction of x-axis to be along with the initial velocity, and the positive direction of y-axis to be the vertically upward direction, and that the x and y components of the motion that can be treated independently, and that the equation of the motions will be x of t equals to x naught plus v naught xt, where yt equals to y naught plus v over t plus half ay t square. Therefore x naught equals to y naught equals to 0, v naught y equals to 0, and ay equals to minus g, which is equals to minus 9.8 meter second inverse square, and vox equals to 15 meter second inverse. So here that stone hits the ground when y of t equals to minus 490 m and minus 490 m equals to minus 1 by 2, 9.8 t square. That will gives t equals to 10 seconds. So here the velocity components that are vx and vox, and that is of vog is equals to minus gt. So that when the stone hits the ground, so vox equals to 15 meter second inverse, voy equals to 0 minus 9.8 into 10, which is equals to minus 98 meter second inverse. Therefore the speed of the stone equals to under root of vx square plus vy square equals to under root 15 square plus 98 square, 99 meter second inverse. Now we're gonna end up with here only, and we'll discuss the rest of the topics in the next coming class. We have a numerical as well, so if we do deal it will be extended, so that we'll discuss in the next coming class. So before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So stay tuned with us, and please like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, we talk about it. So yes, we had done your reasoning. We are in the verbal reasoning and the non-verbal reasoning. We had started with the quantitative aptitude, where we had started with arithmetical ability. We had done the 17th topics there as well. In terms of other than this, we had done your chemistry part 1 for class 11, and chemistry part 2 we are dealing. If talking about for physics, yes, we had done your unit 1, which is your physical world. Unit 2, which is your units and measurement. Unit 3 is your that is motion in a straight line, and unit 4 is your motion in a plane. Then we'll be after completing this, we will be starting discuss about the laws of motion. Then we'll be discussing about work energy power, then system of particles and rotational motion, and then of course the gravitation here that we will be discussing. So here we're gonna end up with thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you. Please like, share and subscribe, so that many and maximum people can get the information at once, and maybe you can also enjoy the video as well. So here we're gonna end up with